Now, in the past, there were older models that were proprietary and were typically controlled by a single vendor. This caused multiple issues, especially in networking, where we have many different devices that need to communicate with each other. Issues resulting from a proprietary model included slow development and no interoperability between vendors. For many years, there's been a major drive to standardize protocols, enhance interoperability, and use open standards. The OSI model was developed by the International Organization for Standardization, or the ISO, and it provides a layered approach to development and interoperability. It allows for multi-vendor interoperability and rapid development. Thus, for example, a web browser like Chrome from Google can run on an HP computer or Dell laptop and connect to a Cisco network, traverse the internet, and connect to a web server running Apache on top of Linux. So your web browser is running perhaps in Windows, or it could be a Safari browser running on a MacBook, connecting across a Cisco network in your corporate environment, traversing multiple devices on the internet, and communicating with a Apache server running on Linux. That kind of interoperability and communication is made a lot simpler because of the OSI model. We have seamless interoperability where traffic is sent between multiple vendors and multiple applications. Now, the OSI model consists of 7 layers, with the advantage that each layer is independent of other layers. The layers of the OSI model, starting from the top, or layer 7, are application, presentation, session, transport, network, data link, and physical. The physical layer is layer 1. When discussing the OSI model, we typically explain and reference it from the bottom up. So we start at layer 1, 2, 3, 4, 5, 6, and end up at 7. There are many different ways to remember the different layers of the OSI model. So for example, all people sleeping through networking don't pass. So you're not going to pass your exam if you sleep through networking presentations. All people sleeping through networking don't pass. There are many other examples, and you'll probably encounter some really funny ones and some which I can't repeat here. Now I'm going to go through each of these layers in a lot of detail in the upcoming videos. Please bear with me because I know this can get a bit tedious and a bit boring, but it's important that you work through these videos to make sure that you have an understanding of the OSI model and the different layers. It's really important to know this, and it's going to help you immensely as a network engineer if you have a good understanding of the OSI model, and you'll find this will help you a lot when troubleshooting networks. There are multiple advantages to the OSI model as mentioned, including interoperability and standards. Another big advantage of the OSI model is split development, or split areas of concern. An application developer, as an example, writing an application like Microsoft Word, doesn't need to understand the details of IP routing. So if you were writing an application and you were, for instance, writing in Python or another high-level programming language, you don't have to understand OSPF or BGP or spanning tree or any one of the many other protocols used at lower layers of the OSI model. Because the different layers are separated from each other, a developer working at layer 7 doesn't need to know what's happening at layer 2 or layer 3.